Question 1.83. Two balls have the same masses, 0.9680 kilogram, and the same charge, 29.59 microcoulomb. They hang from the ceiling on strings of identical length L, as shown in the figure. If the angle on the string with respect to vertical is 29.79 degree, what is the length of the strings? So here you have two identical balls of the same mass m, that is 0.9680 kilogram, and they both have the same charge q, which is 29.59 microcoulomb. Microcoulomb you can write as 29.59 times 10 to the power negative 6 coulomb. And they both make an angle of theta equals 29.79 degree from the vertical when suspended by a rope. We need to find what is the length of this rope. So before we solve for the length, we need to first find what are the forces acting on this ball. Since these balls are identical, I can find forces acting on one of the ball and then solve for the length L. So we can call this ball as 1 and I will call this one as 2. We will find all the forces acting on 1 and calculate the value of length. The first force that we are going to show is force due to gravity, and this force is always acting vertically down. We call it Fg. The second force will be the electrostatic force of repulsion between ball 1 and 2, since they are both positive charge. And because of ball 2, one will be pushed to the left as it will be repelled away by ball 2. We call this force Fe. And since ball 1 is suspended with the help of a rope, there will be a tension along the length of the rope directed towards the point of suspension. We call this force as tension T. The tension force is making an angle theta with the vertical as it is along the length of the string, and the string is also making an angle theta with the vertical. The force due to tension is neither lying on the x-axis nor on the y-axis, so we have to split this force into its component. One component that goes along the y-axis, we call this component t cosine theta. The other component that lies on the x-axis, we call this component t sine theta. Usually the component on the x-axis is taken as cosine theta because we generally have the angle theta with respect to positive x-axis. But here my angle theta is with respect to y-axis. So y-axis is adjacent to theta, and we know the adjacent side is usually related to cosine. Therefore, the y component is t cosine theta and x component is t sine theta. So these are all the forces acting on ball 1. Now, since ball 1 is at rest, as mentioned in the question, the net force acting on the ball has to be 0. So the net force acting along the x-axis as well as the net force acting along the y-axis has to be 0 since the ball is at rest. Therefore, we write F net along x to be equal to 0. The forces acting along x-axis are Fe and t sine theta. So we can write F net x as t sine theta minus Fe equals 0. T sine theta here is positive because it is going to the right. Fe on the other hand is negative because it is pointed towards the left. So you can move Fe to the other side and we get T sine theta equals Fe. I will call this equation 1. We do the same thing along y-axis. Along y-axis we write F net y equals 0. Forces along y-axis are T cosine theta and Fg. So we get T cosine theta minus Fg to be equal to 0. T cosine theta is positive because it is pointing up. Fg is negative because it is going down. Now move fg to the other side. You get t cosine theta equals fg. We call this equation 2. Now I'm going to divide equation 1 and 2. So we do equation 1 divide by equation 2. Therefore, t sine theta over t cosine theta equals Fe over Fg. We can cancel off the common terms, and we also know that sine theta over cosine theta is tan theta. So we write tan theta equals Fe over Fg. Now we know the electrostatic force of attraction or repulsion between two charged objects is K Q1 Q2 over R squared. Since both balls have the same charge, we can write it as KQ squared. The distance between them is d, so in place of r, I will write d squared. Whereas force due to gravity, Fg is m into g. Let us substitute this in this equation. So we get tan theta equals kq squared over d squared into mg. Now I know all the terms in this equation except for d. We can find d from the figure here. If I were to redraw this figure, you will get something like this. The two ropes separated by a distance d and making an angle theta with the vertical. So this distance here, the small one is d by 2, and this is the length L of the rope. Since d is opposite to theta, I can write for this as sine theta equals d by 2 over L, where d by 2 is the opposite side, L is the hypotenuse. And when you rearrange this, you get d equals 2L sine theta. Substitute this for d and you will get tan theta equals kq squared. In place of d, I will write 2L sine theta squared m into g. We need to find, therefore I get tan theta equals kq squared over 2L squared is 4L squared sine squared theta into mg. I want to find L, so cross multiply and move L on the top here, bring tan theta down. So you get L squared equals kq squared over 4mg tan theta sine squared theta. We want to find L and not L squared. So to find L, we have to take the square root of this term, and you get L equals square root kq squared over 4mg tan theta into sine squared theta. Now substitute the values, you get square root k is 9 times 10 to the power 9, q is 29.59 into 10 to the power negative 6 squared over 4 times the mass, which is 0.9680. G is 9.81 times tan of the angle 29.59 into sine of the angle 29.59 squared. Solve, and you should get the length of the string to be equal to 1.211 meter. Now you can use shift solve directly at this point and get the same answer if you do not wish to rearrange the terms.